What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 14 in the 7th grade math questions that North Carolina released this past school year. The question tells us that Janet can make 4/5 of a necklace in 20 minutes, and we're trying to find out how many necklaces to the nearest tenth of a necklace can she make in 1 hour. Now, the two big skills this will test you on are if you know how to use proportions or number tables, and then if you know how to multiply whole numbers by fractions. So let's go ahead and start with just the number table. I'm going to make a very quick little chart where I have one column for the amount of necklace Janet is making and another column for the amount of time. And I'm also going to remind myself that 1 hour is 60 minutes. So if I want to start by filling in some of the information the problem gives me, it starts by saying that Janet can make 4/5 of a necklace in 20 minutes. And we're supposed to use that information to figure out how many necklaces, so this is my blank, can Janet make in 1 hour or 60 minutes. So that's there. So now I'm looking for a pattern, specifically a multiplying or dividing pattern that can get me from the top row to the bottom row or from the right column to the left column. And the easiest one that I can see is that going from top to bottom, we multiply by 3. So 20 times 3 equals 60. 4/5 times 3 equals what? Well, I'll come over to this side and actually do that as a multiplying a fraction by a whole number problem. So 4/5 times 3. And I'll remind myself that this isn't just 3. We can think of it as a fraction and think of it as 3 ones or 3 wholes. So now I just need to multiply across my numerators and denominators. 4 times 3 is 12. 5 times 1 is 5. So this, I'm not sure if North Carolina would take it as an acceptable answer since they said that it had to be the nearest tenth. So I'm actually going to go ahead and try to turn this into a decimal. And specifically, what I'm going to do is I'm going to start by turning it into a mixed number. So I'll see how many times 5 goes into 12, and that's 1, 2, 15 is too many, so 5 goes into 12 2 times. And now 12 minus 10 will give me the number that's supposed to go in this numerator here. So 12 minus 10 is 2. So now I see that 12/5 is equivalent to 2 2/5. Scoot that over a little bit. And now I want to change 2/5 into a decimal. And in order to do that, I'm just going to say that 2/5, if I multiply my numerator and denominator by 2, gives me 4/10. So this means that 2 2/5 is now 2 4/10. And at this point, I can actually go ahead and change 4/10 into a decimal by remembering that 4/10 is an okay way to say both this fraction and, let me scoot this up a little bit, this decimal. So this is a big reason why, if you've been in 4th, 5th, or 6th grade math lately, they might have tried to make you say fractions and decimals the same way. That's so that you could go back and forth from one to the other. So 2 4/10 is now 2 4/10, or you might see it, or you might have heard it read before as 2.4. Now that I know that that is my answer, I just have to plug it into my gridded response boxes. I give each digit and the decimal point their own box. I find my 2 bubble under the 2, my decimal point bubble under the decimal point, and my 4 bubble under the 4, and bubble in each of those.